Hi there and welcome to our video on energy changes. In this video we're going to be going through some exam questions. Our first exam question states the figure below shows magnesium burning in air. Look at the figure above. How can you tell that a chemical reaction is taking place? Now, in this question it's only worth 1 mark. You could have said that a flame is being let off, or you could have said a gas is being released. Okay, and that will get you 1 mark. Name the product from the reaction of magnesium in the figure. Now, because a gas is being released and it's magnesium, you are burning it, so that means it's going to be oxygen. So oxygen is going to be released from magnesium. The magnesium needed heating before it would react. What conclusion can you draw from this? The reaction is reversible. The reaction has a high activation energy. The reaction is exothermic, or magnesium has a high melting point. Now, the correct answer to this is that the reaction has a high activation energy, and that's because you need to heat it so it would react. Remember, the activation energy is the minimum energy required to store a chemical reaction. Now, this one you need to heat it for the chemical reaction to take place. So it has a high activation energy. That will get you 1 mark. Okay. Next question. A sample of the product from the reaction in the figure above was added to water and shaken. Universal indicator was added. The universal indicator turned blue. What is the pH value of the solution? So that's alkaline, so it's going to be 9. Okay, again 1 mark. This question is about the reaction of ethene and bromine. The equation for the reaction is we're given it. Complete the reaction profile in figure 1. Draw labeled arrows to show the energy given out and the activation energy. So this is going to be an exothermic reaction. So that it's going to go a bit like this, a bit like that. Sorry, that's not straight, so I'm just going to draw it again. So it's going to go just like that, and this over here is going to be the activation energy, and if we draw a dotted line over here, this is the energy which is given out. Okay, and that will get you 3 marks. 1 for activation energy, 1 for energy given out, and 1 for that curve. Okay. Next question. Figure 2 shows the displayed formula for the reaction of ethene with bromine. The bond enthalpies or the overall energy change are shown in the table below. Okay, and we're given that table. Use the information in the table and figure 2 to calculate the bond energy for BR bond. Okay, so we need to work out this one over here, and we're not given that in the table, so this is going to be X. Okay, now let's see how many bonds, and we're going to write out something which we can type into the calculator. This question is worth 3 marks. So first of all, there's a double bond between C, and that's going to be 612. So we have 612, and then C is bonded to one bond with H, and that happens 1, 2, 3, 4. So it's going to be plus, where C and H is over here, 412 times 4. So 412 multiplied by 4. Okay, we don't know what bromine is, so if we just work this one out, you can just type that into the calculator. So 612 plus 412 multiplied by 4, that's going to give you 2260, and that doesn't include BR single bond. Okay, now remember, these are the reactants and these are the products. Over here there's a C and a C, and we know that's going to be 348, so we'll write that down. And C is bonded to a H, 1, 2, 3 4 times. So 348 is going to be added to CH is 412. Again, it's going to be multiplied by 4. 412 multiplied by 4. Now C is also with BR, and that happens twice. So it's going to be plus 276 times 2. You can type that into the calculator. So 348 plus 412 multiplied by 4 plus 276 multiplied by 2. That gives you 2548. Now we need to work out this one over here, BR to BR. So to work that out, you will just need to do this one over here, subtract that one there. So we do 2548 subtract 2260. So your answer, subtract 2260. So with 2548 subtract 2260, and that's going to give you 288. Okay, and that's what BR single bond is, 288 for 3 marks. Next question. This question is about ethanol. Ethanol is produced by the reaction of ethene and steam. Figure 1 shows the energy level diagram for the reaction. How does the energy level diagram show that the reaction is exothermic? And clearly over here, the reactants have more energy than the products. Okay, and I will get you 1 mark. A catalyst is used for the reaction. Explain how a catalyst increases the rate of the reaction. So a catalyst lowers the activation energy. So a catalyst lowers the activation energy, and because it lowers the activation energy, it increases the reaction. So it lowers the activation energy, which means that the minimum energy required to start the chemical reaction is not required. So it's taken away, it's taking away that minimum energy. So there's a decrease in the minimum energy, and it speeds up the reaction. Okay, and that will get you 2 marks. Okay, final question now. Explain why, in terms of the energy involved in bond breaking and bond making, the combustion of methane is exothermic. Okay, so how would we do this? So exothermic, we know that the reactants have more energy than the products. And what the graph says about exothermic, we know that it starts here, something like that. On a graph, we know that it's going to be something like that in terms of bond breaking and bond making. So exothermic, more energy is released forming the bonds than breaking the bonds. So more energy is released forming the bonds than breaking them. Okay, and that will get you 3 marks. And that is it for this video. Thanks for watching. I hope you liked it, and one last thing, please subscribe, hit the like button and the notification bell.